Hi Pre-Calc, I'm going to solve this for you. I'm going to do it just like I would ask you to solve it for me on a test. So I'm going to start with Descartes' Rule of Signs. I think you can see it. It's section 2.5, number 69. This is where you use this very sophisticated technique to factor a polynomial that's not easy to factor. All right, Descartes' Rule of Signs, number of positive real zeros. Okay, that's the variation of sign of the original minus even integers. Okay, so that changes sign. It goes from positive to negative. That changes sign. It goes from negative to positive. And that does not change sign. It goes from positive to positive. So there's two, but remember this technique does not account for complex conjugates. So you have to keep subtracting 2 until you get to 0 or 1. I know that's very confusing. Just do your best with that, okay? So it's 2 or 0 because if there's complex numbers in the answer, it always comes in pairs. That's why we subtract 2, because this technique doesn't know if there's complex numbers. All right, now I'm going to do the number of negative real zeros. All right, so for that we have to create g of negative x. So everywhere there's an x in the original, I have to replace it with negative x. Now I'm going to simplify this. So negative x cubed stays negative. This guy right here is going to become positive x squared, but it's being multiplied by negative 3. Okay, so that is not a change. Negative to negative. Not a change. Negative to negative. One change. Okay, and when you get one change, it means there's actually one change. It's not like there might be one change. It's you have one change. All right, the next thing is the rational zero test. And that's again where you take the constant and you put it over the leading coefficient. All right, the constant in this case is a 5. And I'm going to put it over the leading coefficient, which is a 1. And again, don't reduce this if it ends up being reducible, because you're not really writing a fraction. You're trying to look at combinations. So the only way to make a 5, the only factors of 5 are a 1 and a 5. The only factors of 1 are a 1. So the only possible combinations here are plus or minus 1 and plus or minus 5. Okay, so that's the teams really, which is really small. There's just 4 combinations, which is great. There's not a lot of guessing involved. All right, so now we're going to move to the synthetic division, and that's where you try to figure out who the winners are, meaning who the factors are. So again, if I just write out the list, I'm going to write it in order. Okay, that's this list. I'm just writing it in order. All right, so now I'm going to take the original problem. I'm just going to rewrite it here. It's a little easier for me. I'm going to pick something in the middle. So I'm going to go with... Oops, I didn't write it in order. I'm sorry. Negative 5, negative 1, 1, and 5. Okay, I'm going to go with something in the middle. So I know for sure I have one negative. This is where it gets tricky. You know there's 3 answers to this because it's a 3rd degree. But it's a little tricky because I know for sure I have one negative real, but I may or may not have a positive. I may have 2 or I may have none. So just for me, I'm going to start with the negatives because there's a negative. We're 100% sure there's a negative. So I'm going to start with negative 1. It may or may not be correct. I don't know what the answer is. Okay. Okay, I lucked out. I got it, which is great. All right, so let me just again, I know I'm sort of restating myself, but I prefer you understand what we're doing. All right, so again, this is the original. I know it was right here, but I'm going to now use this to show you. So this one that turned out to be a factor, you want to move this to the other side and put it in factored form. Okay, factored form is when it's set equal to 0. Not, this is in x-intercept form, like the x-intercept is equal to -1. This is in factored form when you move it to the left. All right, so we broke the cube function into a linear and a quadratic. This is the quotient here, this is a quadratic. Right, so this is your constant, your coefficient of your linear term, the coefficient of your quadratic term. So I have this. Now, hopefully this factors, but as we can see, it does not factor, and you're still forced to break it down. And if you run into a scenario like this, you have to use the quadratic formula, okay? So let me just write it here. Okay, so you're going to see on the next page, that is the quadratic formula, and I'm going to apply this, because I need this, I need all the zeros, and I need this totally factored. Okay, it'll focus in a minute. I can see it's getting fuzzy on you. All right, let me just rewrite that part. Right now we're just working on this quadratic. You're no longer guessing once it's quadratic. Once you're breaking down a quadratic, you're either factoring using the square root method or using the quadratic formula. Okay, so once you get it quadratic, once you get it down to quadratic, there is no guessing. You're done with guessing. You're done with picking numbers here. You don't do that anymore. Okay? You're done with guessing. You're either gonna try to factor it, or you're gonna use the square root method, or you're gonna use a quadratic formula. Okay, you're gonna use one of those techniques to break it down. All right, so this doesn't factor, the square root method doesn't apply, so I'm stuck using the quadratic formula. So A is 1, B is -4, C is 5. All right, and I wrote the formula earlier for you, so you have it. All right, so remember, when you're solving the quadratic formula, after you plug everything in, most of the work is right here on the radical. You want to first simplify under the radical. So I'm squaring this, and then this part here is you first want to figure out the sign. This is all being multiplied. So it's a negative times a positive, which is negative. I would figure out the sign first and then do the multiplication. So then I'm going to multiply 4 times 1 times 5, which is 20. And again, you just got to stay on the radical for a while. You just got to keep staying on the radical. Now this is going to end up being complex. The negative under the radical comes out as an I. The square root of 4 is 2. You got to make sure you reduce this. So you're going to factor out a 2 and reduce it with the bottom. Okay, make sure you don't like do this. Like, you can't reduce half of the top with all of the bottom. You have to reduce all of the top with the bottom. Okay, that's a common mistake. So you can reduce a common factor with a common denominator. You cannot reduce half the top with all of the bottom. That doesn't make any sense. All these people are on the ship. You can't take half of the people and put it over the entire ship. These other people will be floating out in the ocean. Okay, so just make sure whatever you reduce from the numerator has to go to everybody. I'm already at 10 minutes because you guys know I can chat away. So let's see if I can finish this and hope it doesn't stop on me. All right, so you have to list the zeros. So the zeros are going to be, we got the -1 from before, if you remember that guy. We got the -1 from before, and now we just got the 2 plus or minus I. Now you also have to factor this. In fact, you have to have it in factored form. And that confuses people a little bit, so let me help you with that. So I'll write it here and then move it back. Okay, so when you have this x equals to 2 plus or minus I, that means that x equals to 2 plus I. I'm sorry, I'm going a little fast. I don't want this to cut out at the very end. Okay, so that means you have two things. And remember, in factored form, everything has to move to the left. That's how you put something in factored form. So this in factored form becomes x minus 2 minus I equals to 0, right? If I move everything over to this side, I have to subtract it. This one becomes x minus 2 plus I equals to 0, right? If I move everything in factored form, it goes opposite sign. So now I can write it. I have the x plus 1, right? If you move this to the other side. And then this I was showing you these other two, right? It looks super, super weird. I did x minus 2 minus I, x minus 2 plus I. And that is, okay, that was these that I just showed you before. Okay, that I just showed you before. I put them on the end here. This is them in factored form. I'm trying to get them all on the screen. Okay, I know that looks crazy weird, but in complex numbers, this is what the linear factors look like. This is first degree, first degree, first degree. So altogether, it gives you back the third degree, which is the original problem. So this is listing them as zeros. This is listing the function in its linear factored form. All right, gang, I hope that helped you. And I hope you see also, sometimes you need to see things a few times. I hope also what you put together, since this hasn't cut me off yet, is that you can see that it was 1 negative real and 0 positive. 0 positive real. So it was this guy with this guy. So if you tested the positive, you would have got that none of them worked, and then you would have figured out it was 0, and then you would have gone to this. But so I would sort of start with what you know is definitive, is what I'm saying, versus something that may or may not exist. All right, gang, for some people, this is one of their favorite sections in the course. I hope you're not totally disliking this. It is an interesting process. Okay, gang, I will catch you in another video. Bye-bye.